Okay, we will make a start now. So welcome everyone to our GCSE Maths session. In today's lesson, we are going to be looking at two topics. We're going to be starting off by looking at capture recapture, and then we're going to move on to looking at the product rule for counting. Okay, and all of this is going to be applied with some exam questions. Okay. So first of all, what we're going to do, we're going to start off with a recap of equivalent fractions. So you would have studied this at sort of primary school, year 7, year 8. So it's just it should be a nice recap. Now, when we're talking about equivalent fractions, what we're basically saying is fractions which have the same multiplier on both the numerator and the denominator. For example, if we had a half, we have a half, that's equivalent to something like 5/10 because the same multiplier is present on both the numerator and the denominator. Okay, um, so over here, when we're going from 1 to 5, from numerator to numerator, we have to multiply by 5. And that same multiplier, we have to take from the denominator to denominator. So from 2 to 10, we have to multiply by 5. That's why these are equivalent fractions. Okay, when we've got a half, that's equivalent to 5/10. That is also equivalent to, for example, 2/4, because we multiply the numerator by 2, we also multiply the new denominator by 2. And this fraction is literally the same as a half because the numerator is half of the denominator. If we had sort of 1/3 and I was saying, let's list an equivalent fraction to this numerator and denominator, if we multiplied the top by 2 and we also multiplied the bottom by 2, what would happen is that on the numerator, we would have 1 times 2, which is 2, and we would have 3 times 2, which is 6. So we would have 1/3, and we would have had 2/6. Okay, those are equivalent fractions because we've multiplied both the numerator and the denominator by the same number. We've multiplied them by 2. And it can be any number. As long as you've multiplied the top and the bottom by the same number, it will give you an equivalent fraction. If we had 1/3, and over here we had um, we're looking for another equivalent fraction. For example, let's multiply this by 5. Okay, we would have to multiply the new denominator by the same number as well. We would multiply this by 5 as well, and we would get 5 on the numerator, and we would get 15 on the denominator. These are equivalent fractions because we've multiplied by the same number on both the numerator and the denominator. Now, when we're looking at capture recapture, what you will occasionally see is that you would have something like a fraction like a half, okay, and you would have, actually, let's change that fraction. Okay, I'm just going to change the fraction. Okay. So if we had, for example, 15 over 20, and we had sort of 3 over x. Okay, if we had sort of a fraction like this, what would we do? Well, in this case, we have two, we're going from this fraction to this fraction because we have the unknown on this fraction. 15 to get to 3, what do we have to do? We have to divide by 5. Okay, so on the denominator, we also have to do the same thing. So what I'm trying to get across here is that we don't always multiply. We can divide as well. So if we're going from a bigger fraction to a smaller fraction, we divide. And if we're going from a smaller fraction to a bigger fraction, we multiply. So in this case, we're going from a bigger fraction to a smaller fraction. That's why we're dividing. So 15 to get to 3, we divide by 5. So as perfectly someone said in the chat, 20 divided by 5, we would divide by 5, and we would get x equals 4. Okay, x equals 4 as our final answer. Okay, and that's just a basic recap of equivalent fractions. Okay, equivalent fractions means that you have the same multiplier on the numerator to get from one numerator to one numerator, and you have that same number that you're multiplying from denominator to denominator. It's the exact same sort of multiplier that we have. And this knowledge of equivalent fractions, we are now going to apply to some questions on capture recapture. Okay, now I've got quite a few questions. I think I've got 5 questions on capture recapture, and we're going to work through each of them step by step. Okay, it's not going to be anything sort of put in the deep end. We're going to work through this question step by step. And normally in a GCSE paper or any exam that you are sitting, you would normally get a question like this at least once across the 3 papers that you sit. Okay, so it says, Bhavna has a bag containing a large number of beads. She wants to find an estimate for the number of beads in the bag. Bhavna takes a sample of 30 beads from the bag. She marks each bead with a black cross. She then puts the beads back in the bag. Bhavna shakes the bag. She now takes another sample of 30 beads from the bag, and now 4 of these beads have been marked with a black cross. We need to work out an estimate for the number of beads in the bag. Okay, now if you guys want to have a go at this, feel free to have a go at this and type your answer in the Q&A. And if you're unsure, I'm going through it now as it's our first question. Okay, so let's read through the information. This is a worded problem. Okay, so there's a lot of information that we need to take in. Okay, so it says Bhavna contains a bag containing a large number of beads. She wants to find an estimate. She takes a sample of 30 beads from the bag. She marks each of these beads with a black cross, and then she puts the beads back into the bag. We don't know how many beads that there are. Okay, we've just picked out a sample of 30 beads from the bag. She now shakes the bag, and now she takes another sample of 30 beads from the bag. And now we realize that 4 of these beads have been marked with a black cross. Okay, that's the information that's important and we need to take in. Okay, so let's move on to answering the question. Okay, so we know we are estimating the number of beads in the bag. We don't know how many beads there are in the bag. Okay, so we've picked out 30 beads. Okay, so we've picked out 30 beads out of a total of, we don't know how many beads there actually are in the bag. Okay, so we're just going to call that X. Okay, because we don't know what the total number of beads there are in the bag, so we're just going to call it X. 30 over X, that's it. Okay, because we've picked out 30 and we don't know how many there are in total. Now we're going to make that equal to our second selection. So we've shaped the bag, and now we're going to pick out some more beads. We've picked out 30 beads this time, and 4 of them have been marked. Okay, so originally the 30 beads that we picked out, we marked each of them, and then we put them back in the bag. Then we shook the bag, and then we picked out 30 more beads, and 4 of these have already been marked when we picked out first. Okay, so if we write that as a fraction, 4 of the beads have been marked out of a total of 30. Okay, so 4 of the beads that we have picked out in our second sort of pick have already been marked. Okay, so now as you can see, we've got equivalent fractions here. We just need to make the fractions equivalent. Okay, so as you can see over here, if we're going from 4 to 30, how do we get there? Okay, we need to multiply by something to get from 4 to 30. And if you want to work this out, and if it's a non-calculator paper, all you need to do is the bigger number divided by the smaller number. So all you would do is 30 divided by 4. Okay, and if you work that out, that gives you an answer of 7.5. Okay, so to get from 4 to 30, we have to multiply by 7.5. Okay, now once we've multiplied by 7.5 on the numerator, what are we going to do on the denominator? Because it's equivalent fractions, we have to do the same exact thing on the denominator. So to get from 30 to x, because we are going the same way, we have to also multiply by 7.5. And that's what we're going to do. Okay, and again, you can work this out if it's a non-calculator paper. So 30 multiplied by 7.5 is going to give you an answer of 225. Okay, and I see a lot of correct answers in the chat, so well done, everybody. So working out an estimate for the total number of beads in the bag, our answer is 225 beads. Okay, So just to reiterate, yeah, before we move on to some more examples, the key bits, the key steps that we followed um, is I'm going to write it down now. So the first one is we extracted and highlighted the information. That's what we did. We highlighted the key bits of information. Once we've done that, we set up our first fraction. Okay, and because we are estimating the total number of beads, we don't know the total number of beads. Okay, we don't know the total number of beads. So we've got 30 out of a total population of X. Okay, 30 divided by 4 is not 7.2. So if you do if we just quickly do 30 divided by 4, so if you've got 30 divided by 4, 4 goes into 3 0 times. We carry over the 3. 4 goes into 30 7 times. And we add in a decimal point because we've got a remainder. And then we've got a remainder of 2. And then 4 goes into 20 5 times. So you get an answer of 7.5 if you do 30 divided by 4. And then after that, because we've got 7.5, you then multiply by 30 to get what x is, which is 225. Because 4 to get to 30, we multiply by 7.5. 30 to get to x, we have to do the same because it's equivalent fractions. That's why we multiply by 7.5 to get 225 as your answer. Okay, so if you go back to these steps, once you've extracted and highlighted the info, you set up your first fraction. Because we're finding an estimate for the number of beads in total, x is going to go on the denominator. The third step is you set up your second fraction. Your second fraction is going to be sort of later down in the question. Okay, as you can see, it's this part of the question. Okay, and this time you've selected a population and you're looking at how many have already been marked. So we had 4 marked out of a total of 30. And once you've done that, you work out x by equivalent fractions. Okay, so those are the steps that you need to follow whenever you are sort of answering questions like these. Okay, if you guys have any questions, feel free to let me know in the Q&A. Now, there is one more part to this question. Normally, in an exam, when you get a question like this, you have a part A, which is just like this, and then you also have a part B, and that is what assumptions you have made. Okay, there are some assumptions that you need to make in order to estimate the total number of beads. We've used maths to estimate the total number of beads as 225, but there are some assumptions that we have also made. And those assumptions are none of the crosses have wiped off and none of the tags have fallen off. So if we look back over here, we had 4 of these beads, and we remember when we took out 30 beads from the bag, we marked each bead with a black cross. Now, what if when you're shaking the bag, the black cross rubs out? Then your answer is no longer accurate. So we have assumed that when we shook the bag, none of the black crosses have rubbed out. Okay, and normally this will be the answer. In nearly all of cases, the tag hasn't fallen off or the cross hasn't rubbed off or anything like that. And you'll see when we look at some more examples. Okay, so that's one of the assumptions that we have made. When we've shaken the bag, none of the crosses have wiped off because we mark the crosses, remember, we marked it with black. Now, if we've shaken the bag and because they've rubbed against each other, the crosses have wiped off, we can't control that. So we've assumed that they've not rubbed off, okay, when we've got to this answer. Okay, so we have another example over here. Feel free to have a go at it. I'm going to go through it now. Okay, so it says Carlos wants to find an estimate for the number of ants in a colony. He catches 60 ants from the colony and marks each one with a die. He then returns the ants to the colony. Okay, so we've got a question that have mixed with the population. Is that an option? If the question is about birds. Okay, so yeah, that is a valid sort of answer. So if you've got a question about birds and you've left them out sort of in the surroundings, if they've mixed with the population or migrated or anything of that sort of that such, then Yeah, it would be a valid answer. There is normally a couple of answers, but I normally go for the safe one that is applicable to every question. Um, but 30 divided by 4 gives you 7.2. That's what it gave me. 30 divided by 4, just reiterating over here. You can type your answer in a calculator and check as well. But 30 divided by 4, 4 goes into 3 0 times. 3 is carried over. 4 goes into 37 times with a remainder of 2. 4 goes into 25 times. That's why we've got 7.5. Okay. You can check the answer with the calculator as well, if you want, or you can follow this bus stop method. Okay. Um, so again, if we switch back onto this question over here, it says a week later, Carlos catches another 60 ants. Okay, 8 of these ants are marked with a die. Work out an estimate for the number of ants in the colony. Write down an assumption that you have made. So again, guys, feel free to have a go at this question, but again, I'm going to go through it step by step. Okay, so again, highlighting the main bits of information. He catches 60 ants from the colony. He marks each one with a die. He then returns the ants to the colony. Okay, a week later, Carlos catches another 60 ants. Okay, now 8 of these ants are marked with the die that he initially put in. You need to work out an estimate for the number of ants in the colony, and you have to write down the assumptions that you have made. Okay, so again, yeah, I'm seeing answers. They look all the same, so that's really good. Okay, so first of all, we've highlighted the information. What's our first fraction? Okay, what's our first fraction? So he catches 60 ants. We're estimating the total number of the ants in the colony. Okay, um, so we've got 60 out of a total population of X. Okay, what level are these questions for foundation or higher? So these are basically applicable for sort of the end of a foundation paper and the start of a high paper. So it's a crossover topic, this is. So it would be applicable for both. But again, it's good to get your sort of understanding behind these topics as they're very common in an exam at the end of a foundation paper or at the first sort of few questions of a higher paper. Okay, so we've got 60 divided by x. Okay, so everyone's going for 50. That's really good. So 60 divided by x. X is the total population which we need to work out. Okay, and that's equivalent to what? We need our second fraction. Okay, so a week later, Carlos catches another 60 ants. Okay, so we've caught a 60 ants, and 8 of these are marked with a die. Okay, so we've got 8 marked out of 60. So where did we get these fractions of? Just to reiterate, we're estimating the total population. Okay, we're estimating the total population. That's why we've got x over here, and we've picked our sample of 60. Okay, and then we've got 8 divided by 60 because 8 of these ants are marked out of 60 in total. Okay, now equivalent fractions. So 8 to get to 60, what do we have to do? We're going from a smaller number to a bigger number. So to get the multiplier, we can do 60 divided by 8. Okay, and again, you can work this out using a calculator or the Buster method. 60 divided by 8 gives you 7.5. So we're multiplying by 7.5. Okay, and 60 to get to x, how do we get there? Well, if we're multiplying by 7.5 at the top, then from the bottom, we also need to multiply by 7.5. So if we multiply 7.5 to 60, we get an answer of 450, what everybody got. So well done, everyone, for getting 450. Are these questions the same in higher and foundation paper? Yes. So actually, these questions have been taken from a higher paper, but they are the exact same that you would see on a foundation paper as the higher paper. And would they be on a calculated paper or non-calculated paper? To answer those questions, this can be done without a calculator, but sometimes they don't have enough space to put it into the calculator paper. So they normally opt for the non-calculator paper. But again, this topic, you like, for example, 60 divided by 8, you can work out without a calculator. So you can expect these sorts of questions in calculator or non-calculator. But because you can do it without a calculator, I would say that it's more likely to come up on a non-calculator paper. Okay. Any more questions? Okay. Keep the questions coming in. I'll answer them as soon as I can. But hopefully you guys understand this question. Just to reiterate, we picked out 60 ants out of a total population of something that we didn't know. That's what we're estimating. So we had 60 divided by 6, and that's equivalent to 8 over 60 because we got 8 ants which are marked out of a total of 60 ants that we picked out. Okay, so we've got 8 out of 60. So we've got 60 over x equals 8 over 60. 8 to get to 60, the smaller number to get to the bigger number, we need to multiply. We multiplied by 7.5. So to get from the denominator to the new other denominator, you also need to multiply by the same number, multiplied by 7.5, and you would get an answer of 450. Now, what's an assumption? This would be worth 3 marks. Okay, what's an assumption that we have made? This would get you 2 marks. We need to write a sentence for the assumption that we have made. Okay, and as I said, it's going to be the same answer that you would normally see every single time. Okay, are these questions from a specific past paper website? So these questions are from Maths Genie. So if you want to go onto Maths Genie, it's a very good resource. You can find loads of exam questions. Some of these exam questions I've extracted from past papers as well. I've looked at some of the exam papers that have come up previously, and I've extracted some of the questions that we can have a look at together as well. Okay. So it says write down an assumption that you have made, and it's the same answer every time. As you can see, it's going to be that none. So we've marked each one with a die. So we're assuming that the die hasn't rubbed off. Okay, that's what our assumption is. Okay. And guys, yeah, I will do, but before the session ends, I will do an open Q&A. So if you guys have any questions that are basically not sort of linked to the question, I will do an open Q&A at the end of the session. So you can ask anything that you want sort of 5 minutes before the session, and I'll be on to answer them for you. Okay, so it says the next question again. Have a go at it, type your answer in the Q&A. I'll be going through it for anyone that doesn't understand as of yet. So it says Beth wants to estimate the number of frogs in a lake. She catches a sample of 80 frogs, marks them, and puts them back in the lake. Later that day, in a second sample of 80 frogs, she finds that 10 of them are marked. Work out an estimate for the number of frogs in the lake. Okay, so again, first step, highlight the information. Okay, so we're going to highlight the information. We've got answers already. Well done, everyone. You guys are very fast. So catches a sample of 80 frogs, marks them and puts them back in the lake. Second sample of 80 frogs, 10 of them are marked. We need to work out an estimate for the total number of frogs in the lake. So let's work out this step by step again. First fraction. So we've caught a sample of 80. Okay, so we've extracted a sample of 80. And we don't know how many there are in total. Okay, we don't know how many sort of frogs there are in total. So it's going to be 80 over x. Okay, because we don't know how many there are in total. So that's our first fraction done. That's going to be equivalent to how many we pick out the next time. So the second sample, 80 frogs, and 10 of them have been marked. Okay, so 10 of them have been marked out of 80. Okay, now this is the equivalent fractions. 10 to get to 80, what do? We have to multiply by 8. 80 to get to x, because it's equivalent fractions, we have to do the same. We need to also multiply by 8. Okay, so 80 multiplied by 8 is going to give you an answer of 640, which everybody got. Well done, everyone. Okay, so we've got 640. And write down an assumption, any assumptions that you have made. We just need to list one. And because over here we have marked them, we have assumed that the mark hasn't come off. Okay, they've not specified what sort of mark it is. They've just said a mark. So we've just going to assume that the mark hasn't been sort of, it hasn't fallen off. It hasn't sort of rubbed off or anything like that. So I'm not sure about what assumption means. So assumption means that basically this is maths, right? Okay, we're estimating the total number of frogs in the lake. Okay, we're estimating, we're putting an estimate to how much there are. We can't tell sort of decisively that there are this many frogs in the lake. We're assuming that there are this many frogs. And the reason why we're putting in an assumption is because it's an estimation. This is not sort of the final answer. Okay, um, it's things that you need to consider to get to the correct answer. So we've assumed that the marks haven't been washed off. So we've assumed that the marks haven't been washed off. Okay, so the marks haven't been washed off. Because if they had washed off, then we wouldn't get 10 of them which are marked. Okay, we would get a smaller number which have been marked, and then that would affect our overall answer. So we've assumed that the number of marks that we put in originally, none of them have changed, none of them sort of have disappeared or anything like that. All of them have stayed, and we've picked out 10. Because if some of them had disappeared, then we wouldn't have been able to pick out 10 of them. Okay. Okay, so moving on, next question. Okay, just because of time, there is a question. Okay, so we've got two questions. We'll do one of them. Okay, and then we'll move on to our next topic, which is product rule of counting, which is nothing hard. It's just sort of easy marks that people leave in exams. Okay, so we'll do this question. So it says Ravina wants to find an estimate for the number of birds in a sanctuary. She catches a sample of 70 birds in the sanctuary and tags each of these birds. These birds are then released back into the sanctuary. The next day, she catches a sample of 60 birds in the sanctuary, and 12 of these birds have already been tagged. Work out an estimate for the number of birds in the sanctuary and write down any assumptions that you have made. Okay, so again, first step, highlight the key bits of information. When you go into an exam, you have a highlighter there. So if you want to, you can highlight in an exam as well, or just underline, just so you know where the main bits of info are. This is one of the, sort of the worded problems that you get. You know, you don't normally tend to get worded problems in an exam, but these will always come up as worded. So she catches a sample of 70 birds in the sanctuary and tags each of them, and then releases them back into the sanctuary. Okay, so we've tagged them. The next day, she catches 60 birds in the sanctuary, and 12 of these birds have already been tagged. We need to work out an estimate for the total number in the sanctuary. Okay, so taking this step by step once again. Okay, so first fraction. So we've looked at 70 birds. We've collected a sample of 70 birds out of a total of, we don't know. Okay, we don't know how many birds there are. Okay, so we don't know the total population. So we're just going to call that X. And that's equal to our second fraction. This time we've got 60 birds and 12 of these birds have already been tagged. Okay, so we've got 12 that have been tagged over 60. Okay, so 12 have been tagged over 60 that we caught out. So how do we get from 12 to 70? Okay, again, you can work out or you can use a calculator in this case. Now, this time it doesn't give you a whole number. Okay, so that's something different. It doesn't give you a whole number. 70 divided by 12 doesn't give you a whole number. It gives you a fraction. And because we're going from a smaller number to a bigger number, what we are going to do is we're going to multiply by that fraction, 35 over 6. So, for example, you know, things that you need a calculator for, this question would come up on a calculator paper. The other questions that we did, that you didn't need a calculator because it was giving you nice whole numbers or nice decimals. Over here, it's given you a recurring decimal. So this question would be in a calculator paper. It wouldn't be in a non-calculator paper. So 70 divided by 12 is 35 over 6. So to get from 12 to 70, we need to multiply by 35 over 6. Therefore, to get from 60 to x, you also need to multiply by 35 over 6. Okay? And that's going to give you an answer of 350. Okay? And that's the estimate for the number of birds in the sanctuary. And it says write down any assumptions that you have made. So again, assumption is going to be the same. This time we've used a tag, so we are assuming that none of the tags have rubbed out basically. Okay, so we are going to assume that none of the tags can have rubbed out. Okay, so I'm just going to come back to the Q&A. Just write this. Okay. Okay, so 12 over 60 can be simplified to 1/5, which is easier to calculate for equivalent fraction. Quantity 60 divided by 12, then multiply by 5. So for the second question, I'll come back to the first question and I will explain it again. You can do 60 divided by 12 and then multiply by 5. That is also a proper, that's also a way that you can do it. So that's what you call stratified sampling, and there's a formula that you can follow. The only reason that I teach it this way is basically so that it's more sort of understandable, but you can do 60 divided by 12 and then you can multiply by 5. Okay. 12 over 60 can be simplified to 1/5, which is easier. Okay. Uh, just a minute. Yeah, so you could have done that as well. So over here, 12 over 60, if you've looked at this fraction and you've noticed that this can be simplified, you can simplify it. So 12 over 60 is the same as, if we simplify it, we can divide both by 5. We can divide both by 12, and that would get us 1/5. So 12 over 60 is the same as 1/5. Okay, so if we had 70 over x, that can be the same as 1 over 5, because 12 over 60 is equivalent to 1 over 5. Okay, and if you've realized that, that's really good. That's what they want you to sort of make the question easier. But I didn't realize that 12 over 60, but I've realized it now. So well done for realizing that. So we got 70 over x, and that's equal to 1/5. 1 to get to 70, you need to multiply by 70. 5 to get to 70, you also, 5 to get to x, you need to multiply by 70. Same on the numerator as the denominator. And 70 multiplied by 5 gives you 350. Same exact answer. So that's another way that you could have done it. Okay. Now, I am going to go through this question again, just sort of one last time before we move on to product rule for counting. It won't take that long, the next topic. Okay, I'm just gonna get rid of all my marking and I'll go through my working out again. So it says Ravina wants to find an estimate for the number of birds in the sanctuary. She catches a sample of 70 birds, okay, and tags each of these birds. The birds are released back into the sanctuary. So we've just tagged 70 birds, right? And our main purpose of this question is to estimate the number of birds in the whole sanctuary. Okay, so we've got 70 that we've caught. Okay, we don't know how many there are in total. So we're just going to put it over x, because if anything is out of the denominator, normally tells you everything it's out of. Okay, so we've got 70 out of x because we don't know how many there are in total. We've just picked out 70. and that's equal to the next fraction. So we know that we've got 60 birds, and we know that 12 of these birds have been tagged. Okay, so in the second sample, we've got 12 birds which have been tagged out of a total of 60. Okay, so that's our next fraction, because we've got another sample and 12 of these have been tagged out of the total that we caught, which was 60. Okay, so we have 12 which have been tagged over a total of 60. Okay, now all we need to do is we need to work out a way from getting numerator to numerator and then denominator to denominator. And these are equivalent fractions. So 12 to get to 70, again, if you wanted to, you could simplify 12 over 60. I'm not going to simplify just for the purpose of explaining it, but you could simplify it. 12 to get to 70, how do you do that? You do the same to the denominator. Okay? Um, 12 to get to 70, we need to multiply by a number. And to work out what that number is, you just do 70 divided by 12. You do the bigger number divided by the smaller number. So 70 divided by 12. 12 to get to 70, you multiply by 35 over 6. Okay, if you just type that into a calculator, you can use a calculator for this question. And then to get from 60 to x, you have to do the same as you've done at the top. You also need to multiply by 35 over 6. Okay, so you're going to do 35 over 6 multiplied by 60, and you would get x as 350. And if you wanted to, you can also change this into a fraction, a simplified fraction. So we had 70 over x, and we know that 12 over 60 is the same as 1/5, because 12 to get to 1, you divide by 12, and 60 to get to 5, you also divide by 12. Okay, so we know that 12 over 60 is the same as 1/5. Okay, why do you divide it by 35 over 6? And how do you know that you have to divide it by that number? So over here, we're multiplying by 35 over 6. The reason why we're multiplying by 35 over 6 is because we've basically taken this big number and divided it by that small number, 70 divided by 12, because we need to think of basically something multiplied by 12 gives you 70. Okay, that's why that's why we did 70 divided by 12. So we have something multiplied by 12, and that gives you 70. Okay, now if you divide by 12 on both sides, we get that x is equal to 70 divided by 12. Okay, that's why we work out what 70 divided by 12 is. That gives us 35 over 6. And because we need to do 12 times 35 over 6, that gives you 70. 60 to get to x, we need to do the exact same thing, and we multiply by 35 over 6. Okay, so hopefully that's made more sense. And the assumption, we've already gone through the assumption. Just any more questions? Guys, this is not sort of a real exam question from a past paper. Like, the numbers aren't the exact same as a past paper. They've used sort of random numbers, but the format of the question is the exact same as you would see in a real exam paper. So because I've just said that this would be on a calculator paper, because the numbers aren't that easy to work with, unless you've spotted that 12 over 60 is the same as a fifth, then you wouldn't know that you can divide by easy numbers like that. You would need to use a fraction. That's why I've just said it's a calculator paper. It's not actually come up on a past paper with these exact same numbers, but the style of question has come up. That's why we've used it. What exam board is this? So this topic is made for Excel. However, the content across all the exam boards are the exact same. Okay, it's just the style of the paper that is a bit different. In maths especially, it doesn't really matter what exam board that you are following. Um, all the topics are the exact same across all the exam boards. It's just sort of the total number of marks, the grade boundaries, that sort of thing that differs. Okay, so now before we end off, we're going to go through product rule for counting. Okay, now through these questions, we are working out the overall number of ways of choosing specific combinations. Okay, and this will make more sense. It's really not that hard, this topic. And we're going to have a look at some questions in a minute. Okay, and now these questions are basically questions that many people just sort of leave out, or it just baffles their head. But it's really not that difficult. So it says there are 12 boys and 15 girls in a class. One boy and one girl will be selected to represent the class on the student council. Work out the total number of ways of choosing a boy and a girl. Okay, so we had 12 boys and then we had 15 girls. Okay, now we know that we are going to select one boy and one girl to represent the represent the class on student council. We're just looking at the total number of combinations that we can make. And if we wanted to do it like this, for example, every boy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and every girl will call them letter A, B, C, D. This is going to take forever. Okay, guys, if you're doing AQA, EdXL, it doesn't really matter. This will be relevant for all exam boards. Okay, so don't worry about what exam board you're following. This will be relevant for you because all the content across all the exam board, all the exam boards are the exact same. So this topic will be present on every exam board as well. Okay, so there are 12 boys and 15 girls. Now, simple way to put this, the way that you calculate this is you just multiply the two numbers together. You do 12 multiplied by 15. That's it. Okay, and that will get you the total number of ways of choosing a boy and a girl. Because we had 12 boys and then we had 15 girls, all to work out the total number of combinations that you have, you just need to multiply these two numbers together. Okay, that's it. So you would do 12 times 15, and that would get you 180. Okay, that's it. It's as simple as that. If you're working out the total number of combinations between sort of two categories, um, you just multiply the two numbers together unless you've done something, unless the question is asking something differently. Okay, so we would get 180. What does it mean by total number of ways of choosing one? So basically, let's say we had this, I'll show you a mini example. Okay, I'll show you a mini example. Let's say we had um we had Jack, we had Ben, and um we had Jack, Ben, and Tom. Okay, we had three names. Yeah, these are three boys, and then we had three girls. Okay, so we had Lily, uh Jess, and Lucy. Okay, we had three people, three random people. If we're picking out a boy and a girl, what are the different combinations that you can have Jack and Jilly, you can have Jack and Jess, you can have Jack and Lucy. Okay, you can have Ben and Lily, you can have Ben and Jess, and you can have Ben and Lucy. You can have Tom and Lily, you can have Tom and Jess, and you can have Tom and Lucy. Those are the different combinations that you can have. Okay, and that's what we're doing. But normally, if we have big numbers, for example, if over here we had three boys and we had three girls over here. If we have 12 boys and 15 girls, that's the list is going to be too big. We're going to write out, we're going to draw 180 lines if we were going to do it, if we were going to do it, the whole list, 12 boys and 15 girls. And that's really time consuming. You're not going to sit there in an exam and draw 12 you're not going to write 12 names of boys and 15 names of girls, and you're not going to match them together like that. So the best way to do this is just literally multiply these two numbers. Okay, there are 17 boys and 14 girls in a choir. One boy and one girl will be selected to sing a duet. Work out the total number of ways of choosing a boy and a girl. Okay, now again, it's nothing different. It's the same as the question before. We're working out the different combinations that you can choose. All you need to do is 17 multiplied by 14. Okay, so 17 multiplied by 14, that gives you 238, just as everyone has said. Okay, so we would have 238 as our final answer. Okay, and if where would you see this question? You would see it most likely on a, if the numbers are this nice, then you would see it on a non-calculator paper because you would just need to multiply 17 by 14. If the numbers are a bit more complex, then you may see it on a calculator paper. Okay, so there are 14 boys and X girls in a choir. One boy and one girl will be selected to sing a duet. Taylor says there are 152 different ways of choosing a boy and a girl. Could Taylor be correct? You must show your working out. So remember, same thing. How do we know what the combination is? How many there are? We literally multiply the number of boys multiplied by the number of girls, but we don't know the number of girls. Okay, so we had 14 boys. Okay, we don't know the number of girls, so we're going to multiply it by X because we don't know the number of girls. Okay, and Taylor says there are 152 different ways. So what he's saying that if you multiply the number of boys to the number of girls, yeah, the answer would be 152. That's what he's saying. Okay, is he right? Now if we look at sort of a rearranging formula, we have 14 multiplied by X equals 152. 14 multiplied by X is the same as 14X. Okay, and that's the same as 152. Now we want X to be by itself. To work out X, you need X to be by itself. Okay, at the moment it's being multiplied by this 14. And remember, if you're adding on one side, subtract, multiply, divide. If you need to get rid of a number, all you need to do is you need to do the opposite of it. If you're adding, you subtract. If you're multiplying, you divide, and vice versa. Okay, so over here, to get rid of this 14x, because the 14 is being multiplied, I'm seeing a lot of correct answers in the Q&A. Well done. To get rid of this 14, all you need to do is you divide by 14. And whatever you do to one side, you must do the same to the other side. So you divide this side by 14 as well. Okay, and that gets rid of this 14 because 14 divided by 14 is just 1. Okay, so x is equal to 152 divided by 14. Now, what does 152 divided by 14 give you? 152 divided by 14 gives you 76 over 7, and this is a reoccurring decimal. It gives you 10.857142286. Okay, dot dot dot. That's what it gives you. Can you have 10.857142286 of girls? No, you can't have 10.857142286 of girls. And because the answer is not a whole number, Taylor is not correct because the answer should have given you a whole number. Okay? The answer should have given you a whole number if this was right. If there were 152 combinations, then X should have been a whole number. It doesn't give you a whole number. Because it doesn't give you a whole number, you don't put it into a fraction. You just have to say, no, not correct, because 76 over 7 is not a whole number. Okay, because remember, what is X? What are we trying to work out? We are trying to work out how many girls there are. Okay, you can't have 10.857 dot 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 of girls. It has to be a full number. It has to be a whole number. That's why, because we never got a whole number, um, because we never got a whole number, it can't be correct. Okay. Okay. What we will do is, because I want to leave enough time for a Q&A, we will have a go at this final question over here, because I've seen this question come up in exams. Okay, so it says there are 52 cards in a deck. Okay, there are 52 cards in a deck. Peter is going to give one card to Casper and one card to Kelly. Okay, how many different ways are there of doing this? Okay, guys, please keep on topic. Okay, how many different ways are there of doing this? Okay, so there are 52 cards in one deck, and you're giving one card away from Casper to Kelly. Okay, actually, you're giving one card to Casper, and you're giving one card to Kelly. Okay, so we had 52 cards. Okay, if we give one card to Casper, it can be any of these cards. It can be 52 um, cards. We are any possible card out of the 52 we can give to Casper. Okay, 52 total. Now, if we've given one card to Casper, how many does Kelly have to choose from? Okay, so if you have 52 cards and you've given one to Casper, how many does Kelly have left to choose from? Kelly has 51 cards left to choose from. So there is only 51 cards. Just a minute. Okay, so we had 52 cards. 52 cards. And that's how many Ben has to choose from. And now, okay, 1 minute. This is a different question. Okay, we had 52 cards. We were that Casper has to choose from, and now we've given one card to Casper. How many does Kelly have to choose from? Okay, all you have to do is multiply by 51. That's it, because we have 51 cards left. We've given one to Casper. We have one remain. We have one less. We only have 51, and Kelly has to choose from one of the 51. Okay, so we have 52 times 51, and that gives you an answer of 2,652. Okay, that's all you have to do. Okay, if that's not made sense to anyone, please do let me know. Okay, guys. Because we're on 53 right now, 5:53. I think this is good time, just seeing if there's any. Where did the 51 come from? Okay, so where did the 51 come from? Okay, so basically we've got one person. Yeah, he has 52 cards. Okay, now he's distributing it to two other people. Okay, he's distributing these cards and giving them a choice of picking out a card. Okay, now he gives one card to Casper. Casper has to choose from one of the cards. Okay, he has to choose a card. How many possible cards can he choose from? There's a total of 52 that he can choose from. So he can choose from a total of 52. Now, once he's picked out a card, there's only 51 cards left, right? Okay, because he's picked out one card. Okay, now Kelly only has 51 to choose from. Okay, because 52 have been given to Casper to choose from. Casper's taken one card, so there's only 51 left. That's where we got the 51. And that's why we multiplied the 52 to the 51, because those are the total number of combinations that we have.